Biot-Savart Law. Biot and Savart in 1820 formulated a law telling us about how to calculate the value of the magnetic field around a current carrying conductor. So in 1820, Oersted experimentally found that a current carrying conductor can produce a magnetic field, and Biot and Savart in the same year formulated the law how to find out the magnitude and the direction of that magnetic field. So what they did, this is like an arbitrary shaped current carrying conductor carrying a current I. What they did is they divided this current carrying conductor in infinitely small current carrying element. Let one such small current carrying element is IDL. The line joining the IDL to the point P is the displacement vector, R. R is the displacement vector from the line joining IDL, the current carrying element, to the point P. And theta is the angle that this line joining the displacement vector makes with the current carrying element, or the length of the element. So by calculating the magnitude of the magnetic field at the point P, small magnetic field dB, we can calculate the total magnetic field produced by the whole wire by either using the method of vector addition or by integrating it. So according to Biot and Savart, the magnetic field that is produced at point P, small magnetic field due to the current carrying element ITL, is proportional to the cross product of the current carrying element and the displacement vector R, or is proportional to IDL R sine theta, where theta is the angle between this current carrying element, or the length of the current carrying element, and the radius vector R. So this is also proportional. This magnetic field, small magnetic field dB, is also proportional to the inverse or inversely proportional to the cube of the displacement vector, or cube of the distance from the point to the current carrying element. When I join these two equations, so dB becomes equal to proportional to IDL R sine theta over R cube, or dB vector quantity is proportional to IDL sine theta over R squared. In order for me to remove this proportionality sign, I need a constant, and the value of the constant is mu0 over 4 pi, where mu0 is nothing but the permeability of the free space. Means how many magnetic field lines are permitted by this medium, where this point where I'm trying to find out the value of the magnetic field and this current carrying element is located. The value of mu0 over 4 pi is 10 to the power minus 7, and the unit is Weber over ampere times meter. So my final expression for the dB comes out to be 10 to the power minus 7 IDL sine theta over R squared. Now the total magnetic field due to the whole current carrying wire can be can be obtained by adding the factor sum of all these small current carrying elements, or can be determined by integrating this small magnetic field within some given limits, depending upon the shape of the conductor. Now, how to find out the direction of the magnetic field at the point P? For that, there are two rules. There are many rules, but the first one rule that I like to use all the time is right hand palm rule. And then if I stretch my right hand in such a way that my thumb is in the direction of the current, and my fingers are pointing towards a point where I have to find out the direction of the magnetic field, then my palm will represent the direction of the magnetic field. So you'll see if I try to stretch my right hand and point my fingers towards a point, then my palm is vertically inside the plane of this paper. So this magnetic field at this point P is vertically inside the plane of the paper. Or let's say if I have another arbitrary point, let's say P prime, at this point, I want to find out the direction of the magnetic field. Then I will have to put my thumb again in the direction of the current, and my fingers, when I try to put it towards the point P, have to flip my hand so my palm is facing upward. So the direction of the magnetic field at this point is a dot. Means the magnetic field is vertically outside the plane of the paper. And at this point P, the magnetic field is vertically inside the plane of the paper. To understand the meaning of this cross and dot, go back to my last video where I have explained how they determine cross and dot and what is the significance of this. In the next video, I'm going to talk about the magnetic field produced by a straight current carrying conductor and by other various different current carrying elements, different shape current carrying elements. Thank you.